Hi, my name is Amy. Thank you very much for watching. So, I got a late start today. I had one of those brain cycles where I just stayed up till 3 a.m. because I did. Um, so then I was slow this morning. I got my groceries. I had a large breakfast, did not have lunch. So, um, I told my boss I wasn't working today, have worked today, have been in several meetings today. Such a weird day. Nothing's ever goes as planned, but now we're just gonna do this. I paid the ad tax. I got my private key and I put it in my environmental variable. So hopefully we can kind of just get through this without me showing it to you, which is why we wound up not, getting through the 8 hours and 20 minutes last night to get through lesson 5, but, we're almost there. We're almost to lesson 6, and I'm hoping to get through lesson 6 today, or at least almost to lesson 6 done. It's a little much to ask that we go through lesson 6 and 7, but at least we know we're going to get through lesson 5 because there's only 20 minutes of video left on that, and it would have to be something super duper wrong. My cat insists she's a part of this live stream. What do you want, sweetheart? What is wrong with the world? No? No, we just get butts. Okay. You're welcome to be more a part of this live stream if you want to be. But yeah, as soon as I sent that Twitter invite, my cat went from my lap to the tree, which is fine. We can do that. She's fine. We're all fine. Everything's great. We need to start watching this video though, or I'm gonna spend 3 hours explaining why we can get through 20 minutes of video. So.
Has actual money in it. A quick way to check is by going to your networks tab and seeing if on any of the main nets or the networks with actual money in it, you see any money. I don't have any money in this, so I know I'm good to go. If you have testnet money, that's fine because that's fake money anyways. Again, most browsers have a profile mechanism where you can create a new profile for you to use. But here, now that I've copied my private key, we can come back to our Visual Studio Code, paste the key in here, and now I have a private key that has actual Rinkeby in it. Awesome. And remember, if you ever get low, just come over to faucets.chain.link/Rinkeby, get some test ETH. I'm not a robot. We'll send the request. Sure? Now that we have our private key and our Rinkeby in here, we can now try to run this on an actual testnet. If we look at our code, we see we're grabbing an RPC URL, which is going to be from our .env. We're grabbing a private key, which is going to be from our .env, which points to our Rinkeby MetaMask and our Rinkeby blockchain. So let's just add a console.log under our contract deployment so that we know what address it's at. We'll do console.log. We'll do some string interpolation, contract, address, contract.address.
Okay, so in here we are going to deploy, and then we've defined contract here, and we basically were just like console.log that might be a function. Is that a function?
All right, great.
No, it is not a function. Just kidding. So, npm run deploy. Sorry, wow. No. What did we do? Invalid password. By the way, did I turn off display? No, I did not. Not yet. See, I wanted to do this without showing you my password. Okay, so let me turn off my display for a second. I will definitely remember to turn that back on. Going into ENV, Command F, and I'm looking, and it is the same thing. I'm going to put it in double quotes because sometimes my ENV, it doesn't read it correct. And then I close the file and turn display back on. Should have checked this to make sure that it's working before I turned the tutorial back on. Okay. Does it look the same as Patrick's? Contract equals contract wait deploy. His address has 3 S's, but the contract.address is the important part. So we've got wallet address and we have contract address, and then I don't really want to okay, first of all, save. Invalid password. Oh, if we go to the encrypted JSON. Oh, this might be because the encrypted JSON, we used the private key password and the contract private key. Let me rerun that script and see if changing that stuff helps, because I think that might be the issue, is that we're using the encrypted thing, right? Let's see if I feel like he snuck up on us with this because he has the binary stuff. Contract binary. Does it?
And now let's go ahead and run this. We'll do node deploy.js. Deploying, please wait. You'll notice this takes a lot longer because we're deploying to a test.
Well, I mean, I'm noticing that there is an error. Kind of want to go back and do this from not the encrypted JSON, but also let me okay, this is fine, I guess. Okay, so we have the private key password. If we go to the encrypt key, we have the private key password and the contract private key. I mean, of course this is happening. I feel called out. Here is the GitHub. This is the lesson 5. I did not want to show you my private key, but hey, the whole 0 people that are ever going to watch this, or 1, I guess, hopefully not malicious people. Also, it is a dev-only wallet, so there is that. Okay. So we went over, oh, you know what? We went over a lot of things, and I think it would be better if we changed the wallet back to I should probably organize that a little bit better, but whatever. We still have the deploy.js. And deploy.js, we're keeping, I wouldn't say clean per se, but comment that out. So the wallet is the private key and the provider, and then the Okay. So what did we just do? It does not look like it errored, so there's that. No, it did error. Cannot estimate gas. Transaction may fail or require manual gas limit. So if we go to my MetaMask, to FA. I think we're trying to do Grilly. It could be Ring B at this point. Cannot. Okay, so we don't need to see the wallet address anymore because it is connecting to the correct wallet. So there's that. Then, rejected. Remember we had like the TX stuff in here? Okay, so this. What am I looking at? This transaction here. I think the send TX transaction response is manual, and Ethers.js is supposed to help with that. So, what am I connected to? We have the alchemy. Where do we find the so alchemy's here. Okay, so this says that um does this contract have ETH? This isn't the original question either. I have Gorelli. I have Rinkeby. I don't have Ethereum. I have a little bit of Coven. I don't have any Sepolia, but I don't know what that is. We can just back up. I don't really want to. What am I looking for?
Instead of our own fake.
We're at 8 minutes and 3 seconds. Sorry, 8 hours and 3 minutes. What I'm looking for is we got the contract. Okay, so the RBC
is we can select our app that we just made, and we can.
So we're here. We're in. I'm signed in. Here. View key. So this the HTTPS
what we can do now is we can select our app that we just made, and we can hit view key, and we can see here we get an API key, we get an HTTP endpoint, and we also get a WebSocket. We're only concerned with the HTTP endpoint. This is going to be our RPCRL that connects.
So then we come back here. Okay, so this RPC URL is either not correct or it has the same. Okay, so ethers, and we say I'm wondering, so inside of deploy.js, this is not that. Inside of deploy.js, we have the wallet. At what point does it fail? Is no one going to tell me that's not how you actually spell actually? Okay. Okay. Can we just do like contract factory dot gas equals to in their GitHub, inside of their actual GitHub, inside of the wow, you're kind of a jerk. So the thing is here, that's telling me to define gas price. It's eth-rinkb that they have. This is maintenance. See, this is where the issue comes in. Well, there's several issues here. I'd like to delete. Okay, so if I come here and I view this key, I copy this, and this no longer says maintenance. Well, you get Okay, so when I set it up before, I was not very bushashin. I was not very careful. So this is taking a while. Not making a while. It is taking a while. We're good.
Next to ring beat. So what we can do now is we can copy this. We can come over to our Visual Studio Code, and in our .env, we can substitute these out for their actual testnet values. So for RPC-URL, we're going to delete this and replace it with our RinkB RPC-URL. And now, how do we get a private key for an actual testnet that has actual RinkB on it? Well, here is where we can use our MetaMasks. So back in your browser, go over to your MetaMask, select the 3 dots, go to Account Details, Export Private Key, and this is where you can export your private key. Type in your password, and boom, you now have your private key for your account on MetaMask. Now remember, please, please, please don't continue with a MetaMask that has actual money in it. A quick way to check is by going to your Networks tab and seeing if on any of the main nets or the networks with actual money in it, you see any money. I don't have any money in this, so I know I'm good to go. If you have testnet money, that's fine because that's fake money anyways. And again, most browsers have a profile mechanism where you can create a new profile for you to use. But here, now that I've copied my private key, we can come back to our Visual Studio Code, paste the key in here, and now I have a private key that has actual RinkB in it. Awesome. And remember, if you ever get low, just come over to faucets.chain.link/RinkB, get some test ETH, I'm not a robot, we'll send the request. Now that we have our private key and our RinkB in here, we can now try to run this on an actual testnet. If we look at our code, we see we're grabbing an RPC-URL, which is going to be from our .env. We're grabbing a private key, which is going to be from our .env, which points to our RinkB MetaMask and our RinkB blockchain. So let's just add a console.log under our contract deployment so that we know what address it's at. So we'll do console.log. We'll do some string interpolation, contract address, contract.address. All right, great. And now let's go ahead and run this. So we'll do node deploy.js. Deploying, please wait. You'll notice this takes a lot longer because we're deploying to a testnet instead of our own fake local blockchain. Testnets and real.
I should have done the please wait before the deploy. But I think you can see refresh one transaction in the last hour. It was this. Yeah, so we were successful to any stretch of the imagination.
Networks often will take a little bit longer because they need to wait for the blocks to propagate, the transaction to go through, etc. But after a brief delay, we will indeed see that we get a contract address here. And we have a current favorite number. And it's being a little slow again.
Also, I'm using OBS with Restream. Does Restream have a way for me to see does it have a way for me to see who's commenting on things, or are we kind of SOL? That's fine. We're cool. Just looking at my coffee mug. Do I even have... I do have liquid in here. We're never getting past these cursed 3 minutes. Mostly because I said, oh, we will get through the next 20 minutes, no issues.
Because we're waiting for our next transaction to go through to update the number, and boom, it looks like we've successfully updated it. Now, something that's important to know, if ever you run a command and you want to kill it, you can do Control-C, and that will stop it. So any command in the terminal that you want to just abort, Control-C is your get out of jail free card, and that will kill it, that will stop it wherever it is. So we'll use Control-C a lot in the future. So now let's grab this contract address and go over to RinkB Etherscan.
Well, we use Gorelli, first of all. But double click. go URL .etherscan. And look, hey, there's transaction histories on this.
Paste it in. We can see our 2 transactions here. We can see we have a contract creation. We can also see we call a store function. This is awesome. We've successfully deployed a contract to the Rinkeby chain using our own code. Congratulations, this is massive. Now on Etherscan, we actually can verify and publish our contract code. What is verifying and publishing your code? Well, right now, our code looks like a huge jarble of bytecode. And anybody looking at our contract directly on chain will just see this huge jarble of bytecode. We could use a decompiler to try to decompile the bytecode into what it looks like in Solidity, but this can often take a long time and a lot of processing power. So instead, we can just make it much easier by verifying and publishing the code ourselves. If you go ahead and hit verify and publish, we can scroll down and we can add compiler information to compile this on Etherscan and other block explorers. This is a single file. Compiler version is 0.8.7, and its open source license is MIT. Let's go ahead and continue. And we're going to copy paste our Solidity code into this large section.
Okay. This is literally cursed. Okay, so we're gonna go to, where are we? Okay, so we're in Gorilla, Etherscan. These are the transaction details. Let's go to the contract section. Okay, so please enter CE5, yeah, and then compile type, it is a single file. Then it is we go to here, we have 8.17, I believe. I agree to the terms of service. Oh, wait. Okay, so enter the Solidity contract below, which is this one. Over here. We have the ABI, which is inside the compiled folder. We'll go through this with him.
Time and a lot of processing power. So instead, we can just make it much easier by verifying and publishing the code ourselves. If you go ahead and hit verify and publish, we can scroll down and we can add compiler information to compile this on Etherscan and other block explorers. This is a single file. Compiler version is 0.8.7, and its open source license is MIT. Let's go ahead and continue. And we're going to copy paste our Solidity code into this large section. Paste. We don't have any constructor arguments, so we can skip this section. We don't have any libraries or any other.
Oh, I guess we are just going to leave that blank. Well, okay. Wait, are you... Oh, wait, but we don't need to do that.
Miscellaneous settings.
I am not a robot. Let me just verify and publish.
We'll select I'm not a robot. And we'll hit verify and publish.
Okay. Whee, gears, go us. Wheels are turning. Okay, we are verified and we are published.
You might have to wait a few minutes, but awesome, our contract was successfully compiled. Now, if we go back to contract source code, we can see all the code in here. And if we grab our contract address, place it into...
Okay, why am I going back so much today? So we go back to the contract address. It's here. Whee!
Our contract was successfully compiled. Now, if we go back to contract source code, we can see all the code in here. And if we grab our contract address, place it in...
Grab the contract address again. Why don't we just do it from the command line over here? Here. Come back to the here's. We'll just search this again, eh? And now we go to... The contract has a green check mark now. And it doesn't look like a bunch of bullshit. It looks like code.
Place into the search now, and we go to contract, we get a little green check mark, and we can see anybody can now read our source code. Additionally, those buttons that we saw in Remix for reading from our contract and writing to our contract are in this read contract and this write contract. If we read the...
So you have the code... Oh, okay, so you can read. You went to 256, and it is currently at 42. We can change that, and then write contract. We have add person, and we have store. Store changes the value of a favorite number. So instead of this, that's cool.
Contract, and we retrieve the most recent number. We do indeed see that we have 7 here because we recently stored 7.
Do we not have do I not have people? Okay. So I don't think we have... I wanted to change this instead of it being 42, which we pass as a string, but it's close enough. It's smart enough not to, or to know for it to not be Oh, it's not deployed yet. We are at here. Favorite number is 0. Okay. That's fine. At least it's not 42 anymore, eh? It's still 42. I just wanted to change it so that oh, okay. But it's still 42. So either this is wrong, I didn't actually do anything, or okay, so all of this is weird. But if we go to alchemy 15 minutes ago, just now, I want third web to work on my M1 laptop. So this is BS. Why is my favorite num? I feel like this is one of those things where why would it still be 42 and not like replaced? You know? Okay, so this has just this one from 17 minutes ago. And not, maybe it takes a little bit to come up here. Who knows? We'll go on with the tutorial.
Awesome. Quick note, this might already be verified for you since Etherscan might get smart enough to notice that a lot of people are deploying the same bytecode. If it's already verified for you, just go ahead and walk through these steps anyways. Now, the code verification we just did was pretty simple and straightforward because our code was pretty simple and straightforward. Using larger and more complex code can make the verification process a little bit harder. Additionally, we don't always want to have to click buttons on Etherscan to verify our code. We want to do it programmatically. So in later sections, we'll learn how to verify all of our code directly through our code editor. You can imagine the process is this easy for deploying to any EVM chain. In our Alchemy, we could easily create a new app and change our network. And you can see how easy it would be to just switch out this RPC URL and your private key to work on a different chain. This process is also the same for Harmony, Phantom, Avalanche, etc. And if we wanted to switch chains, we would just switch the RPC URL and switch the private key, and everything else would stay exactly the same. Now, Alchemy also shows us and can teach us a lot about transactions and about things that are going on behind the scenes, including a concept called the mempool. To help us understand a little bit more about those transactions that we just sent and how to work with Alchemy to see more about our transactions, we have Albert from the Alchemy team to give us a little demonstration.
Hello, Albert here from Alchemy. I'm at that guy in tech on Twitter. Feel free to follow if you want to engage and ask any questions about this section of the video. But super excited to join Patrick here to explain a little bit of what goes on behind the scenes when you are using Alchemy to submit a...
So, at that guy on Twitter. Oh, wait, this is not the right. Also, don't tell anybody. And it's my DMs are open. And Is it this guy? Who is this? That guy in tech. Okay. Sure. Show everybody all of my lists. I just want to be alerted. Say like large tech accounts. The reason why I'm doing this is I want to know about him, but he's not going to follow me back, so I don't necessarily care to follow him. Yeah. We'll get through this, and then I'm going to find out what I'm not supposed to be telling anybody about.
On Twitter. Feel free to follow if you want to engage and ask any questions about this section of the video. But super excited to join Patrick here to explain a little bit of what goes on behind the scenes when you are using Alchemy to submit a transaction. And we have a ton of tools to actually provide a window of visibility into what's going on so that you can actually debug in case there are usage errors on your website or there are pending transactions that are stuck. Whatever it is, we provide that window into the data that you control. Remember that all the transactions that you submit are recorded on the blockchain. They're not controlled by Alchemy. They're not controlled by any other service provider. We are just a window. We're just the plumbing, the piping to be useful to you. So let me show you exactly what that means. Right now, I have a bunch of applications in my dashboard. You can see here that there are different projects that I've used over time. This one is the most recently active, and it is the one that I have currently set up to connect to my MetaMask. So I actually use a custom RPC provider here. Let me make my face a little smaller. And you can see here, I've misspelled Rinkeby, but this, right now, my network is actually connected to the Rinkeby test network via Alchemy. So this is actually this application. So if I click into here in the dashboard, you can see here a bunch of really interesting statistics. This is the first thing that you'll probably use if you're trying to understand more about your application. You'll go here and you can see how many compute units per second your application is currently using. And this is kind of great for specifically Alchemy usage understanding. But then this is also really useful to see, like, what's the median response time? And so 33 milliseconds is pretty good. If that starts to increase, then you might want to figure out, what's going on here. Success rate, it has been kind of low. So that is a clue for me to click on this tab to view recent invalid requests. And that I can actually see, oh, there's a bunch of failed transactions where the transaction has already been sent or the nonce is too low or whatever it is. I can actually use this tab to debug. So that success rate is pretty useful. Throughput, that's been limited. So if you are sending too many requests or your website is getting spammed, you might start getting some of the requests blocked. So that's what's useful to view there. Concurrent requests over here, success rate in the past 24 hours versus the past 1 hour. The total number of requests in the last 24 hours. And this is different than compute units because each request can have a different level of computing cost. And computing cost is measured by compute units. Total requests is just the actual number of absolute requests. And then, of course, the number of invalid requests. Cool. So one thing I do want to show you that's interesting is when I do submit a transaction, and I actually have one right here that I want to send. So let's transfer between my accounts. And I'm just going to send a tiny amount of Rinkeby ETH, but I'm going to purposefully edit my gas fees to be super, super low so that the node will actually not send the transaction to be mined, or there are no miners that will actually pick it up. So you can see here, I've divided the priority fee and the max fee by a ton. So it's super low. And if I confirm that, in the MetaMask UI, you'll see that the transaction has been pending for a bit. And we'll go over to this mempool tab. This is another really useful visualization. And what the mempool is a kind of a holding ground. I like to think of it as the waiting room of a restaurant, where if you're a transaction and you're waiting to get mined, the mempool is kind of like the waiting room where you're waiting to get seated. So there are different statuses for each of your transactions. The ones that you always want to see are the mined transactions, because that says that your transaction is successful and it's now part of the blockchain. Now, the mempool, every node has its own holding ground. So I can actually show you this quick visualization. Remember, blockchains are run by a network of nodes, and each node or each computer that's running the Ethereum software maintains a copy of the blockchain. And as a developer, you have to use these nodes to make requests to the blockchain. You can use Alchemy, you can use another RPC provider, you can spin up your own node if you want to, but regardless, you need to use a node to communicate with the chain. Now, each node, beyond having a copy of the entire blockchain state, it also has a local memory of transaction.
Okay, I just looked at his web browser, and holy poop, he has like 1,000 Confluence. 1, 2, 3, 4, 5, 6, 8 that are visible Confluence, and like almost as many YouTube videos, and then PowerPoint and spreadsheet, a bunch of Twitter tabs. I don't know how anybody works like this. I have to close my tabs every once in a while. It helps declutter everything. My actual house cluttered. My laptop browser tabs. It gets a little ridiculous if I am looking something up, but once the task is done or I'm starting for the day, it has to be cleaned off. There's just an impressive amount of browser tabs.
And that's called mempool. So if there are pending transactions that are waiting to be mined, you can consider them as being in the mempool. Now that's what we're looking at right here. If we click on the app that I am currently using for my MetaMask RPC, then you can see here that there are, this is not the right one. This one is the right one for Rinkeby. For all the transactions here, you can see some were dropped and placed, some were mined, and there's one that's pending. And this pending one actually matches up with the one that is pending here. It's being sent to 0xCBB. And if we click on this transaction hash, you get all the information that you need to debug. So you can see here that it's from my current address, 0xF5F, and then it's to 0xCBB. And here's the value that I'm trying to send. Here's the gas fee that I'm attached to this transaction. And you'll notice that that is super low, even for the Rinkeby test network. So knowing this and seeing, wow, this transaction's been pending for 1 minute and 46 seconds. It was sent at this time. I should probably fix that. And so over here, you can actually use the MetaMask RPC, the MetaMask API, and speed it up. And then I'm just going to use the auto high speed up to update the gas fees. And then if we go back to our dashboard, back to our application, you can see that there are some new recent invalid requests, and this is because we've resubmitted a transaction. And then in the recent requests, we have, let's refresh that real quick. You can see that we are sending a raw transaction. This one's already known, and there's another one before, but that's resulting in a get transaction receipt that is successful. And then if we go back to the mempool, you can see, boom, no more pending transactions, only dropped and replaced and mined. So this transaction nonce number 5 is now successful, and you're on your way to developing and maintaining the rest of your application. So yeah, thanks. Hope that was useful. Let me know if you have any questions.
Thanks, Albert.
Now, other than the TypeScript portion, which I'll do at the end, you've successfully completed this section. And wow, you've learned a ton. Let's do a quick review of everything that we've learned. Well, first, we've learned how to create new projects with Node.js. We've learned what the node keyword does and how we can use the node keyword to run JavaScript in our local development environment. We learned that we can add different dependencies of external packages into our local package using yarn or npm. And we can see those dependencies added in package.json. We know that they've been installed because they get installed into the node modules folder. We can also create a script section where we can minimize long commands that we need to run into a single keyword. Like compile, for example, we can just run yarn compile to compile all of our code. We learned the basic setup of our JavaScript scripts. We import our packages at the top. We have some main executor function at the bottom. And then we have our main function in the middle. We use the async keyword so that our function can use asynchronous programming. And we get access to the await keyword, which basically means, hey, wait for this promise to finish doing its thing. We're able to connect to any blockchain we want using an RPC URL. And then we're able to connect our provider to a wallet or a private key in Ethers by doing something like this. Speaking of which, we've learned about the Ethers package, which is a tool that makes our life a lot easier to interact with the blockchain in JavaScript. If we decide to, we've also learned we can encrypt our private keys so that even if our computers get hacked, our private keys aren't lying around in plain text. And we've learned how to run scripts from our encrypted keys. We've learned how to get the ABI, or the application binary interface, and the binary of our code to deploy to a blockchain. We've learned how to deploy our contracts to a blockchain programmatically, and then we've learned how to interact with our contracts programmatically as well. Additionally, we've learned how to add a default editor in our settings.json of our VS Code, but we've also learned how to override those settings by adding prettier using a .prettier RC file. This way, we can auto-format our code to make it look a lot nicer and much easier to read. Finally, we learned how to deploy one of these contracts to a real testnet or a real network, and then we finally learned the manual way to verify our contract source code. Like I said, we're going to learn a lot of shortcuts and a lot of ways to make this all a little bit easier in coming sections. Whew! You have done phenomenally to reach this section. Give yourself a pat on the back, take a break, go for a lap, and feel really proud about yourself that you made it this far. We've got a lot more to go, but you have come a phenomenally long way. Congratulations. Go take that 5 to 10 minute break and come back when you're ready.
Look. We're allowed to take tiny breaks every time we have these mini things. It took me 135 days to get 8 hours into this. The majority, at least half of this, was done within the last 3 days. So, I personally am happy with myself. Give me a couple minutes and then we will, well, let's get through the next 3 minutes and then let me take a little bit of a break. There's really only so much. So many excuses, but training really does. It takes a lot of power for yourself to concentrate and absorb and understand. So, yeah.
Now, the one thing left I want to show you all is the TypeScript edition of this. However, if you're not interested in the TypeScript edition, which you don't have to be, then you're done. There's only a couple of changes we need to make this TypeScript compatible. First, of course, we're going to change our deploy.ts and encrypt key. We're going to change our deploy and our encrypt key from .js to .ts. And then we're also going to swap these requires out for imports. So we're going to import ethers from ethers. We're going to import star as fs from fs extra. And then we're going to import .dmv/config. And then we're just going to copy these and we're going to come over and paste them into here.
Okay. Why don't we cp deploy.js to deploy, and I don't give a shit about the other one being converted to TypeScript, but yeah, import and then import star as fs from fs extra. And then import .env.config. Is that what we're doing? /config. And then some of this, it's like
deleting or commenting out the requires. Okay, great. Now, if we try to run node deploy.ts, we're going to get
I love getting errors.
Cannot use import statement outside of a module. In JavaScript, if we'd want to use an import statement outside of a module, we'd come in here and do something like type module like that. But in TypeScript, we actually don't even need that. All we need to do is run this in TypeScript node. So to add TypeScript, we're going to do yarn add TypeScript. And we're also going to add ts
npm s before you hit enter.
node. TS node is the TypeScript edition of node. So now that we've added that, we can try ts node deploy.t.
Okay. Please stop doing that. Thank you. Okay. It does not like. So get very contract. It is an object. We'll just put any. We need to get the contract factory interface. Oh, this is a bunch of BS. Does this run?
Yes, and we're still going to run into an error. And if you scroll up, we're going to get a couple errors here. We're going to say, could not find a declaration file for module fs extra. We need to add the TypeScript version of them. So we're going to do yarn add types / fs extra, like that. And if we run it again, it still shouldn't work, but for a different.
You're so close.
fs extra. We need to add the TypeScript version of them. So we're going to do yarn add types / fs extra.
Is fs extra even? npm I at types fs extra. Oh,
like that. And if we run it again, it still shouldn't work, but for a different reason. Yes, we're going to get something like this. Type undefined is not assignable to type bytes-like. The reason we get this is because process.env private key in TypeScript technically is type string or undefined. So we need to tell TypeScript, and the wallet objects and the encrypt function is looking for type string, not string or undefined. So we just need to tell TypeScript that this will not be undefined. So we can just put a bang here.
Bang, bang into the room. Oh no, I'm going to get demonetized. And by demonetized, I mean I'm not monetized in the first place, but you know, the usual. So but you put the bang there. So basically,
and everywhere that we use process.env.
it's not gonna be undefined. Oh, it's only in 2 places. So.
Oops, I gotta do that on deploy as well. Bang, bang. Looks good. Now that we've added everything in here, we run ts node deploy.ts. We're going to see the exact same output as we saw with just using reg.
Oh, you know what? The gas limit. TypeScript is good. I should probably be writing code in that because it's now become standard more than even, you know, Vue or React. And while it is seen as the enemy, it really is, it helps with a lot of errors without even having to test your code. As long as you do the correct thing and not just do any like I do. The weirdest thing about TypeScript is they expect that you know what you're working with before you get it. And to me, that's like the weirdest part about all of this. So yeah, my manager at my day job is being respectful of me just being like, no man, not working for the rest of the week. So tomorrow I have a few meetings, but other than that, I'm not working. I'm not afraid. I can't live stream while I'm in the meeting because they're probably going to be talking about things that should not be live streamed. But it is the all hands, the first all hands of the being acquired. And why is favorite number 0? That's dumb. We'll see. I did something wrong. But hey, it works, so we can get on with our lives.
Regular node, and as long as our private key password is in our .env file, if we run ts node encrypt key.ts, we're going to get the exact same setup as before, and we're going to get a new encrypted key.json. And that's all you need to do to make this TypeScript compatible. And you should give yourself a huge round of applause for getting this far and learning what's going on underneath Hardhat, the next tool that we're going to learn, and learning all about these transactions and how to interact with these blockchains. This is absolutely massive. So huge congratulations.
Okay, well, I could have gone a little bit longer of him congratulating me. So I think I am gonna end this live stream, but I'll be back in a few minutes. Just let me piss around for a bit. Yeah, that was the longest 20 minutes. That was about an hour and 20 minutes to get through 20 minutes of lesson. So, yeah, let me take a break and then I will be back. So, I'll see you.